Pure water has a pH of 7, which is an equal concentration of hydrogen to hydroxide. We saw that ocean water is a basic pH, slightly basic, because there are other compounds dissolved in the ocean water. The same is true about rainwater. So rainwater is not pure water. There are other compounds dissolved in rainwater, and when this is naturally acidic, it's due to extra hydrogen ions. So how those extra hydrogen ions are present is all natural. It's because there's atmospheric carbon dioxide. So carbon dioxide is a gas, and when carbon dioxide in the atmosphere meets water in the atmosphere, which is rain, water is something that can dissolve many things and can easily dissolve the carbon dioxide gas. So once the carbon dioxide becomes aqueous, it will dissolve and react with the water and produce carbonic acid. This is the exact same first step as ocean acidification. So this is just the combining of carbon dioxide with H2O to get H2CO3. Carbonic acid is a weak acid, and what strong acids and weak acids do is they dissociate. So this weak acid will break apart into the hydrogen ion, and this is bicarbonate, HCO3-. And the end result of these series of reactions is different from the ocean acidification because what you have here is just increased hydrogen ion. So the increase in hydrogen ion means that there's a decrease in pH. Remember, it's an inverse relationship between hydrogen ion concentration and pH. So this will decrease the natural pH of water is 7, and this brings the pH of rain naturally down to somewhere between 5 and 6. So we can test the pH of rainwater. Things about rain. We know that rain is naturally acidic, and it's naturally acidic because of atmospheric carbon dioxide that's dissolved into the rainwater, and through a series of reactions generates hydrogen ions in the water, same as with ocean acidification. But unlike the ocean, rainwater starts off a pH of 7 and then falls to a lower than pH of 7, making rainwater naturally acidic, less than 7, usually around 5 or 6. So I collected some rainwater when it rained last week, and then let's wait for this to equilibrate. So this is the pH of rainwater collected in Los Angeles in the week of April 10th, and let's see what we get. So this is not a pH of 7. Basically between a pH of 5 and 6, so rainwater is naturally acidic. The natural pH of rainwater is between 5 and 6, and this is not called acid rain. It's just the naturally acidic rainwater. When you have acid rain, it's because there are even more hydrogen ions and an even lower pH. So acid rain has a pH of less than 5. And why there are additional hydrogen ions is due to air pollutants. So there are two main categories of air pollutants. There's the sulfur dioxide, so those are called SOx, either SO2 or SO3, and the X stands for having the different number of oxygens. So the SO2 is the air pollutant produced by coal-fired power plants. So those are factories and generating electricity. And when sulfur dioxide is a gas, it's in the atmosphere. This, when it meets up with water, dissolves the sulfur dioxide gas and it becomes aqueous and reacts with the water. So this is just a similar combination of SO2 and H2O to produce H2SO3, which is a weak acid, sulfurous acid. So like all weak or strong acids, it breaks apart into the ions, and you get this hydrogen ion in addition to the anion, this sulfite anion. So the hydrogen ion is what's important. This is how there are additional hydrogen ions in rainwater when you start with sulfur dioxide. So you can see sulfur dioxide doesn't have any hydrogen ion, but it's a series of reactions that lead to production of hydrogen ion in the rainwater. So when there are additional hydrogen ions, this causes the lowered pH. Remember, it's an inverse relationship. And so this is how we have a pH less than 5 when there are sulfur dioxide. So the NOx air pollutants, that's either one oxygen or two oxygens, and nitrogen dioxide is the air pollutant that originates from transportation sources when nitrogen gas and oxygen gas are a side reaction on a hot gasoline combustion engine. So this produces nitrogen dioxide in the engine exhaust. And this nitrogen dioxide is also a gas in the atmosphere. And when it meets with water, so this would be rainwater in the atmosphere, water can dissolve many things, and it can even dissolve this nitrogen dioxide and then react with the nitrogen dioxide, ultimately producing nitric acid, HNO3. And like all weak and strong acids, nitric acid breaks apart into the ions. The ions you get are H plus and NO3 minus, that's the nitrate ion. And so having increased hydrogen ion in the rainwater leads to an even lowered pH value. So this is another way to get acid rain. And this is, again, starting from NO2, nitrogen dioxide, that does not have hydrogen. It's a series of reactions that leads to the production of hydrogen in rainwater. So both of these air pollutants result in acid rain. The source is different. So here's another nice thing. If we can reduce air pollution, well, that's good because cleaner air. Another thing about reducing air pollution is that it solves the problem of acid rain.